Hi, and welcome to a brand new video. Today we're going to be tackling the right side of the tree problem. In this problem, we're given a binary tree, and all we need to do is create a list of integers of the right side of the tree. So here it'd be 1, 3, 4, because that's the right side of the tree. If I change this to, let's say, a forward slash here, and I move the 4 here, then it'd still be 1, 3, 4, because that is the very first element that we see on the right side. So in order to code this, we're just going to first talk a little bit about the logic. What will we be using in order to code this? In this example right here, I kind of put up a binary tree. And you notice that we have a couple of lefts and rights. I'm going to kind of show you what is going to be the answer for this. So as we can probably tell, we have this left node, which is 1, then we have 2, 6, 8, and 9. But what does this mean coding-wise? If we take the binary tree and look at every single level, so we see this is the first level, we see that this is the second level, we see this is the third level, we see this is the fourth level, and we see this is the fifth level. So in every single level, we're taking the very last integer. So if every single level was, let's say, in an array, we're taking that last element in the array. So here we're taking 1, which is the last element. We have 2, 6, 8, 9. And this analogy with using each level and taking that last node is how we're going to be solving this question. We'll put every single row inside an list. And then we can just take that last element in order to make our answer. So let's get to the coding. Here is the coding console. And in here, what we're going to, I've set up a method that kind of has the return of a list that we've been talking about, the method name, and it's taking in a tree. So the first thing we want to do is that if a root is equal to null, we're just going to return a new array list because that means that we have nothing. The root is empty and there's nothing for us to do. The next thing I want to do is I'm going to kind of make a list for every single level. Sadly, there isn't like a built-in method for this, but we can recurse through every single node and put it inside the list based on which level it is. Does that sound familiar? Based on which level it is, we're going to put it inside an array. That kind of sounds like a hash map to me, having the key value be the level and having the value be a list of the other values inside that level. So we're going to create a private variable, and it's going to be a hash map from integer, which is going to be the level, to an array list. And I'm just going to call this map. So this is going to kind of have the level to the integers inside that level. Inside my method, I'm going to instantiate this hash map. So now we have created our hash map. In order to iterate through all the nodes and add it to the appropriate level, I'm actually going to be using a recursive function for this. So let's create a new function here. It's going to be private. It's going to also be static. And I'm going to call it recursion because that's kind of what we're going to be doing. And I'm going to be accepting two parameters, the tree node and the level that it's at. Okay, great. So at a certain node that we accept, there's going to be two scenarios. The first scenario is that the hash map already has a running list. So, for example, if I added, if I was at this node, if I was at 3, then 2 would already be inside the list for this level. So, but if I was, let's say, at the 2, then there is no running list so far. I have to create a new key value pair for the hash map. So for this condition, we're going to use an if map.contains key of level. This means that it already has a list for the level. And then else, it doesn't. We need to create one. So in order to I just add this value to the existing map, we're going to do array.get level. So that will get the list at the hash map position. And we're going to do dot add root.val. So what we're doing here is, oh, I'm sorry, not array, I mean map. So we're getting at the map, we're going to get the value because we know it contains it. If it's inside this if statement, that means it already has a list of all the other numbers inside the level. So we're going to do map.getLevel.add root.val, remember because it's a array list. Else we need to add one. So what I'm going to do is I'm going to create a new array list, integer, and I'm just going to call it temp. This is going to be a new array list, kind of like so. Then what I'm going to do is I'm going to take temp and I'm just going to add root.val to it. So now we kind of have an array list of the very first value inside that level, and all we have to do is do map.put the key, which is level, and the array list, which is temp. So what I did here, just to review, we see whether our map of each level inside the binary tree, if it already exists, then we're only going to add this value to it. If it doesn't exist, we're just going to create a new key.value pair for this level. And then obviously, because this is a recursive function, we need to go to the next nodes. So if root.left not equal to null, recursion of root.left and level plus 1, because remember it's a new level. And if root.right not equal to null, we're just going to do the same thing. Go to level plus 1. And recursion. Seems like we're getting an error, so let's take a look. Oh, that's because we forgot to put the return type here. So just put void as the return type. So when you're doing this program, make sure that you put the root.left first, because we want the nodes on the left side to be put first so that the last element can be the value that's put last. If you switch it up, instead of getting the very last element, you're going to get the first element, which is definitely okay, but just be sure of which one you're putting first. So now we're done with our recursive function. Now I'm going to go back into our main method, and I'm going to do recursive of root and 1 because the very first root is going to be at level 1. And this will just, inside the hash map, now we're going to have each level have a stored, each level will have a list of which integers are inside that level, which is what we want. Now comes the simple part. I'm going to create a new array list, and it's going to be called ans because that is what I'm going to be returning, ans for answer. And for each array list, x inside the hash map that we've created, then all I want to do is I'm going to do ans.add x.get x.size minus 1. What this will do, it'll take the very last element inside our array list and is going to add it to this answer. And I'm going to return ans. Because in the problem we want to get the very last number inside each level, that's why I'm going to create a list. I'm going to add every last number to that list and I'm going to return that list. So that might be a little bit complicated, but as you kind of walk through it, you'll notice that all we did was that we got what nodes were in each level, and then we just took the very last node inside each level, kind of like I explained on the PowerPoint slide. If you do have any questions, feel free to drop them in the comments and I'll respond as soon as I can. So now if we run this program, you notice that we got 1, 4, 5. So let's take a look at the example that I created. So the example that I created has a 1 at the top, and then the left one will be a 2, the right one is a 3, and then down here on the right, oh, this is why we created a mistake. Here, I accidentally overrid this part, so I actually meant to put a 3 here. So now, let's run this again, and now we got the answer that we have here in this example. So congratulations on completing this problem. Like I said, it was a little bit tough, but I know you could have done it. See you in the next video.